When you create your own classes in Java, many times you're going to override some methods from the class called object. Those methods primarily are the toString method, the equals method, and the hashCode method. Now toString makes a lot of sense. toString says give me a string representation of the class, or rather the instance that I'm working with at the moment. And equals makes some sense. Equals is trying to establish some kind of equivalence relationship, but a lot of people get confused on what hashCode means and what the proper mechanism is in order to implement equals and hashCode in general. Now, returning to the employee class, it's an abstract class here. I'm going to let my IDE generate a toString method, and then we'll talk about it. So if I say I want to put in a toString method here, then it prompts me to say which fields out of the class do I want to assemble in my toString method. And they have various templates as well, using toString with concatenation and super and all of that. I could change things around. I'm going to use all of the attributes and just use concatenation, and this is what I wind up with. So in this case, my toString method returns the name of the class and then a brace, and then they append on ID equals, comma, name equals, comma, hire date equals, and then close the brace. And this is effectively a string representation of the value of the attributes of the object, the state of the object, if you will, using the class name. Now, by the way, one of the nice things in my IntelliJ IDE here is if I do an Alt-Enter somewhere in here, I can change that to a string.format, and you can see now I have a formatted string with the same values, and that takes the format takes a formatted string and then a variable argument list of all the values to plug in at the various spots. So ID will get plugged in the %ID, and name at the %s, and hire date at the %s as well. And that will sometimes lead to a somewhat easier to read formatted string rather than doing all the string concatenation. But it's the same basic idea, same principle going on. So that's a toString method. They're not terribly complicated. They're not terribly hard to understand. If I look at my use HR again, let me take out all my breakpoints from the previous demonstration. Again, if I just want to print everybody, I don't even need to deal with the payment right now. Then when I execute this one, you'll see there's the execution of the default toString method, the one I just generated rather, IDs, names, and hire dates. Now before I finish that, just as a demonstration, if I comment this out and I run again, this is the default toString method from object. You can see what you get is fully qualified class name, so package.class, followed by a literal @ sign, followed by some hex representation of the memory address where this object is stored. That is almost, but not quite, completely useless. I mean, it's not totally useless. It does tell you at least what class we're dealing with, but as a default, it's not really all that beneficial. And this means that just about everybody overrides the toString method. It's probably the most overridden method in all of Java. It's also a nice example of polymorphism, that we are invoking toString on an object and it's using the one that we provided. So at any rate, that's the toString method. There's not a whole lot more to it than that. The next question becomes the equals method and the hashCode method. Now let me generate equals and hashCode, and then we'll talk about them separately. So first of all, here's my generated equals and hashCode method. Now they're saying, do I accept subclasses as a parameter of the equals method? And this is actually a fundamental dilemma in object-oriented programming. Is a salaried employee equal to an employee? And again, you use the word equal, and that's kind of awkward. What we really mean is equivalent. Is a salary employee equivalent to an employee? And most of the time the answer would be no, but you can come up with examples where you might say, yeah, but if they have the same primary key in the database, then they might as well be equivalent. I'm dealing with the same object. And it's really a bit of a discussion as to whether to allow that or not. As they say here, while generally incompliant to object.equals specification, accepting subclasses might be necessary for generated methods to work correctly with frameworks, which generate proxy subclasses, and they specifically bring up the dominant object relational mapping framework in the industry, Hibernate. So the question is, are we going to allow it or not? And I'll allow it, and then we'll see what the consequence of that is. When I hit next, then it says which fields do we want included in our equals method. And again, if we were talking about an entity mapped to a database table, you might want to say simply based on the ID, that's the only thing that matters. If I have two objects that have the same ID, they're the same object. But in this case, I'm going to look at the equivalence of all of these properties, ID, name, and hire date. Then it asks which fields to be included in the hash code, and I'll simply say that they should be consistent with the equals method. You basically want the hash code. Well, the contract is if two objects are equal by the equals method, they should hash to the same value. Now, we haven't talked about hash code yet, but that's the basic idea, and we'll come back to that. So since I used all three of those properties for the equals method, I might as well use all three for the hash code method as well. Are any of these non-null? They will also check, or rather the generated method will check to see whether these are null. I'm not going to get into that issue right now. And then here is the generated equals method and the hashcode method. But let's start with the equals method. First of all, where does this algorithm come from anyway? Now, I got it from my IDE, but where did the IDE get it? Back in the late 90s, there was a book written called Effective Java, which was a list of recipes that was written by an author by the name of Josh Bloch, B-L-O-C-H, and he at the time worked for Sun and then eventually worked for Google, who is the creator of the collections framework, among other parts of the language. And he wrote out a prescription inside his Effective Java book on how to override equals, how to override hashcode, how to make them consistent, to make sure that you override hashcode when you override equals. And every IDE since then has basically adopted that prescription. So let's look at some of the details. Now, first of all, this is an equals method and takes an object O as an argument. It's a beginner trap to put in your own equals method that would take an employee as an argument, because that's not an override, that's an overload. Remember, to override the method from object, you have to match the signature exactly, and that's what this is doing. This is matching the signature from object. You can even see the arrow here pointing that out, and if I click on it, this is the implementation in object. See, here's the object class, and notice what the implementation is. It's the equals equals method using this and the argument. Not the equals equals method, it's equals equals operator. The equals equals operator returns true if both references are pointing to the exact same object and false otherwise. So I could have two employees with the same ID, the same name, and the same hire date. They would still return false by the equals method at the moment because they are separate objects. That's why we're overriding it. So the default implementation of equals in object is the equals equals operator. So returning to the one we have here, it first starts off by saying, look, if this equals equals O, in fact, if we are pointing to the same object, then just return true. We don't need to do any further checking. We're all set on that. But then this is the one that deals with child classes or not. And this one says, if O instance of employee is false, return false. The issue here, however, is that instance of returns true for children as well. If I had said that children were not allowed, we would get a get class. We would check equality of the class references, because then only employees could be employees. It wouldn't have anything to do with children. You couldn't say that a salaried was equivalent to an employee. The problem with this, or rather the controversial part of this, is that O instance of employee will return true even for a salaried employee being compared to an hourly. And you have to decide whether or not that's what you want, whether that's the behavior that you find acceptable or not. At any rate, if we're comparing something that isn't in the employee hierarchy, then we might as well return false. There's no need to check anything else right now. So good. Now that we know this is an instance of employee or one of its children, we can cast the argument to type employee, and that's what's being done here. Now we can check the individual properties. If the current ID, the ID of the current object, is not null, then if the ID does not equal the argument's ID, then we're done. Else, if the ID, the other employee's ID is not null. In other words, this is more complicated than it should be, or seems to be, because they're dealing with nulls. In other words, if ID is not null, then we just check whether the IDs match or not, and if they don't match, we're done. But we're also checking to say, look, if our ID is null and their ID is also null, that's fine. We'll go on and check the names after that. So that's what this first line does. Line 53 here checks the ID property. Line 54 checks the name property. Again, if the names don't match, or if we're not null and they are, or vice versa, then we're done. We're out. But if both the IDs match and the names match, then we'll go check the higher dates as well. Same process. If the higher dates match, then I guess all of them match and we're done. If our higher date is null and theirs isn't, or actually if it's not null, then we go ahead and invoke this. Otherwise, we check to see whether their higher date is also null. So in other words, if the higher dates are the same by the equals method, we're good. And if they're not if we're null and they're null, we're also good. And that's how they compose the equals method here. They first check to see that the references point to different objects, or if they point to the same object, we can just say true right now. Then we check to make sure that the argument is in fact an employee, and then cast it. And now we check the individual properties one by one to make sure that they're consistent. Now again, equals methods are reasonably intuitive. I mean, we are simply checking to see if the value of each attribute that we care about is matching the one in the argument. And we also have the little added complexity of checking for nulls. The question is, what's the deal with hashCode? Now, here's my little example to discuss what hashcodes are about. Now, I have a class here called store numbers. And the goal of store numbers is to say, I'm going to hand you a bunch of numbers between, say, 0 and 99, less than 100. And then later I'm going to say, hey, did I ask you to store 2? Did I ask you to store 55? Did I ask you to store 17? And I want an answer back in constant time. I want to know right away. It doesn't matter where the number is in that collection. I just want back true or false right away. So I want the retrieval to be very rapid. Well, for integers, especially integers that are relatively small, the solution to this problem is very straightforward. You make an array of Booleans. So here is my array of Booleans called numbers, and it's a Boolean array of size 100, and that means the indices run from 0 to 99, and it's all of those values are initialized to false. This is private. When I tell you to store a number, then use that number as the index to the array and set the value in the array to true. So that means if I say store 3, then you go to numbers square bracket 3 and set that to true, or store 47, you set numbers square bracket 47 to true. And the benefit of that is that later if I say, hey, is stored 47, you just returned the value of the array at that index and you're done. So for example, down here in the main method, I instantiated the class and I said is 2 stored, and then store it, and then I ask it again, and this is what it looks like when I run it. You'll see when I first say is 2 stored, it's false, and then I store 2, and then I say is it stored, and now I get back true. So that what this has enabled is a very rapid lookup of whether or not I'd asked you to save a particular value. And for numbers, this is great. Now, what if I came back to you and said, however, I'd like to store strings now? What are you going to do? Because you can't use a string as an argument to a Boolean array unless you convert it to an integer. If you convert all those strings to integers, then now you are able to use an array for the storage mechanism and again play this game of putting in true or false. Now, the mechanism of converting an object into an integer is the hashCode. That's what we're after with the hashCode. Now, what it enables is rapid lookup of stored objects. Now, the issues that come up with this, first of all, I only was asking you to store like 100 numbers, the indices from 0 to 99. If I asked you to store 10 million numbers, I can't make an array that big. Even if I have enough RAM, it just doesn't work. Also, if I ask you to store strings, well, there's an infinite number of strings. How am I going to determine what the number should be from that? And the way a hashCode algorithm works is you try to make it so that the values are reasonably well distributed into the collection to make the searches a little bit faster. And also, you want to make it so that if two strings have different values, they're not likely to hash to the same value. Now remember the contract. The contract says if two objects are equal by the equals method, they must hash to the same value. That's what you want. If the equals says they're equivalent, then they should have the same hash code. But if equals says they're different, they can have different hash codes or not. Of course, ideally, we would like them to have different hash codes. So with this in mind, let's go look at that hashCode method that was generated. So again, this is the algorithm based on the recommendation by Josh Block. It says, let's start off with a value here. And it says, all right, our result is an ID. Now the ID in this case was an int, so they simply check to see if it's not null. If it's not null, grab its hash code, and if it is null, just start with 0. Then they're going to introduce an offset. They pick a prime number, in this case 31, and multiply it by the result, and then they have the next prescription for converting a number into an integer. So again, now they take the name and invoke its hash code, and the hire date and invoke its hash code, and each time introducing the offset and returning a result. So the idea is if the ID, the name, and the hire date match for both objects, then this algorithm will produce the same result. But it's very unlikely that different IDs, names, and hire dates will hash to the same value. For example, say all I was doing was storing an object that had two integers in it, an x and a y, and I was simply saying my hash code is the sum, x plus y. Well, 5 and 3 would hash to the same value as 4 and 4, and that's not necessarily what we want. So by introducing the offset, then we've made it very unlikely for objects that are not equivalent to hash to the same value. Now, I had earlier a task class as well. And the task class has an integer and a string and a couple of local dates and another int and a Boolean. Let's take a look at what the generated hashCode method is there. The equals method is the exact same process. Again, check to see if the objects are the same, the references are pointing to the same object, check to make sure we're at least looking at a task, cast it, and then check the properties one by one. On the hashCode method, again, we start off with the ID, and then we add in an offset for the name, and the start date, and the end date, and the priority, and for a Boolean completed, it's a 1 or a 0. If I had a double, they would use some sort of left shift to get properties off of that. In other words, there are mechanisms recommended for each of the primitive data types in Java, and that's what a hashCode method's all about. Now, finally, why do we care? When we move to our collections discussion, which is coming a little bit later, the collection known as a set does not allow storage of duplicates. If you try to add a duplicate item to a set, it doesn't fail or anything, it simply doesn't add it. And how does it know the two objects are duplicates? For the equals, it uses the equals method and the hashCode method. You have to override both in order for the set to work properly. And that's why we generate both equals method and hashCode method overrides when we work with that. Now there are some other methods in Object as well, namely waits and notifies, and we'll come back to those when we talk about concurrency in that section. But hopefully this gives you enough background to understand the normal toString overrides, the equals method overrides, and the hashCode method overrides, and when you would need them and why.